Good day everyone. So today, we are going to solve some problem in chapter 6, fluid flow measurement.
So in a test to determine the discharge of coefficient of 50 mm times 12.5 mm venturi meter, the total weight of the water passing the meter in 5 minutes was 340 kilograms. A mercury differential gauge connected to the inlet and throat of the meter showed an average mercury difference during that time of 360 mm. So letter A, compute the velocity of the throat, and letter B, compute the theoretical discharge. So this is the figure for our venturi meter. So A, let us compute the velocity of the throat. So in this problem, let us use the Bernoulli equation. V1 squared over 2g plus P1 over specific weight plus Z1 is equal to V2 squared over 2g plus P2 over specific weight plus Z2. And as we can see in our figure, Z1 and Z2 is in the same elevation, so it can be cancelled. And we are left with V1 squared over 2g plus P1 over specific weight is equal to V2 squared over 2g plus P2 over specific weight. Then we have V2 squared minus the V1 over 2g is equal to P1 minus the P2 over specific weight. Next, we will use the continuity equation. A2 V2 is equals to A1 V2. Our area A2 is equals to pi over 4 50 squared V2 is equal to the area in 1 or A1 is pi over 4 12.5 squared V1 as it is 50 mm times 12.5 mm. Next, plugging it in our calculator, we have V2 is equal to 16 V1. Summing up water heads from point 1 and 2, we have P1 over unit weight plus H minus 0.36 times 13.6 minus H minus 0.36 is equal to P2 over specific weight. So our P1 minus P2 over specific weight now is equal to 4.536. Then 16 V1 squared minus V1 squared over 2 times 9.81 is equal to 4.536 as this is the value for our P1 minus P2 over specific weight, the 4.536. So, computing this, V1 is equal to 0.59 meter per second and V2 is equal to 16 times 0.59. So, the value for V2 now is equal to 9.44 meter per second. Next, let us solve for our theoretical discharge. So we use QT is equal to A1 times V1. So our area 1 is pi over 4 times 0.05 squared times 0.59. Plugging it in our calculator, we get 0.00116 cubic meter per second. And this is the answer for our theoretical discharge.